Good morning and Sairam to all. In previous video we have started our new chapter of physics, chapter 5th, sound. In previous video we have already done the introduction part of sound and some other topics. Now in this video we are going to cover remaining topics and some topics has been deleted by the CBSE. So before going to start our today's lecture, we will do a quick revision what we have learnt in previous video. So let us start. We know that sound is a form of energy and sound is that form of energy which make us hear. Clear? So with the help of sound waves, we are able to hear the voice of another person. Clear? A wave is a vibratory disturbance in a medium which carries energy from one point to another without there being a direct contact with the 2 points. Is this clear? Now we have already done that there are 2 types of wave. Number 1, longitudinal wave. Number 2, transverse wave. How many types of waves are there? There are 2 types of waves. Number 1, longitudinal. Number 1, longitudinal, and second one is transverse waves. Number 1 is longitudinal wave and number 2 is transverse wave. So basically your sound waves are longitudinal waves. Basically your sound waves are your longitudinal waves. Now a wave in which the particles of medium vibrate back and forth in the same direction in which the wave is moving is called a longitudinal wave. Like this, as like a spring, like this. It will come and then come back to and fro. It's clear? So the wave which travel along a spring when it is pushed and pulled at one end are called your longitudinal wave, like this. Clear? First they will form compression, then rear friction, again compression, again rear friction. Is this clear? Now, the sound waves in air are longitudinal wave. The wave produced in the air when a guitar wire or a sitar wire is plucked are the longitudinal wave. Clear? A compression is a part of a longitudinal wave in which the particles of the medium are closer one another. I told you that in a longitudinal wave compression and rear friction will form. So the compression when the particles are very closed and the rear friction when particles are far from each other. Is this clear? So a compression is that part of longitudinal wave in which the particles of the medium are closer to one another. The particles of medium are closer to one another than they normally are, and there is a momentary reduction in volume of the medium. And a rear friction is that part of longitudinal wave in which the particles of the medium are farther apart than normal, and there is momentary increase in the volume of the medium. Is this clear? A wave in which the particles of the medium vibrates up and down, like this. Clear? That type of wave is known as your transverse wave. I am repeating once more. A wave in which the particles of the medium vibrate up and down at right angle to the direction of which wave is moving is called a transverse wave. Clear? The waves produced by moving one end of a long spring up and down rapidly, whose other end is fixed, is known as your transverse waves, like the water waves or ripples formed on the surface of the water in the ponds are also a transverse wave. When you throw a stone into the water, some waves will produce. That type of wave is known as your transverse wave. That type of wave is known as your transverse waves. A transverse wave travels horizontally in a medium. Transverse waves travels horizontally in a medium. The particles of the medium vibrates up and down in the vertical direction. Clear? Now, here crust and trough are also there. The upper part is known as, see like this. This is your graphical representation. This is known as your crust. This is known as your crust and this is known as your trough. Clear? Now let us start with the today's lecture. In today's lecture we are going to cover characteristics of sound wave. What we are going to cover? We are going to cover characteristics of sound. So first characteristic is frequency. First characteristic is frequency. It is represented by small f like this. Clear? Now the term frequency tell us the rate at which the waves are produced by their source. Clear? Basically frequency tell us a rate at which number of waves are produced. So with this, we can write the definition of frequency. What do you mean by frequency? The number of complete waves produced in a 1 second. Produced in a 1 second is called frequency of the wave. Clear? Since one complete wave is produced by full vibration of the vibrating body. With this, we can say that the number of vibration produced per second is called a frequency. What do you mean by frequency? Number of oscillation or number of vibration produced in a per second is called frequency. So here the definition, the number of oscillation per unit time is called the frequency of the sound wave, and it is earlier it is represented by nu. It's a Greek word letter, but nowadays it is represented by small f. Is this clear? And its SI unit is hertz. Its SI unit is hertz and it is represented by capital H and small z like this. Clear? What do you mean by frequency? The number of oscillation per unit time is called the frequency of the sound wave. And it is earlier it is represented by nu, but nowadays it is represented by a small f, and its SI unit is hertz. Its SI unit is hertz. Is this clear? Now what is the relationship between the frequency and the time? Basically frequency is inversely proportional to time period. Is this clear? Basically your frequency is inversely proportional to your time period. So f is inversely proportional to 1 by t. So what do you mean by inversely proportional? I told you that inversely proportional means if your frequency will increase, your frequency will increase, your time period will decrease, and vice versa. Is this clear? Now are you able to see this? See, if your wavelength, we will study later, if your wavelength will short, that means higher the frequency. If your frequency is higher, that means sound is high. Is this clear? That means shorter the wavelength, higher the frequency. Higher the frequency, high the sound. Is this clear? Shorter the wavelength, higher the frequency. Higher the frequency means high sound will produce. Is this clear? Now the next one is if your wavelength is longer. If your wavelength is longer, in that case your frequency will low, and if your frequency will low, in that case your sound will also low. Is this clear? Now moving to the next characteristic, that is time period. That is time period. So what do you mean by time period? time, it's very simple. The time required to produce one complete wave, the time required to produce one complete wave is known as your time period. So the time taken for the change in density of the medium from a maximum value to a minimum value and again to the maximum value is called a time period. This is a typical scientific language, but if you want to write in a simple language, you can write that the time taken for one complete oscillation in the density of the medium is called the time period of the sound wave. Is this clear? It is represented by letter capital T. It is represented by capital T. It is represented by capital T. And its SI unit is second. Its SI unit is second. And frequency and the time represented as follows. I told you that T is inversely proportional to 1 by F. If time will increase, your frequency will decrease. Clear? So I'm reading once more. Listen carefully. The time taken for the change in the density of the medium from a maximum value to a minimum value and again to the maximum value is the time period of the sound wave. The time taken for one complete oscillation in the density of a medium is called the time period of the sound wave. It is represented by the letter T. It is represented by the letter T and the SI unit is second. Frequency and time are represented as follows. T is equal to 1 by V or F. Now the next one is amplitude. The next one is amplitude. So when a wave passes through a medium, the particles of medium get displaced temporarily from their original undisturbed position. Is this clear? What? When a wave passes through a medium, the particles of the medium get displaced temporarily from their original undisturbed position. The maximum displacement of the particle of the medium from their original undisturbed position when a wave passes through the medium is called amplitude. Basically, जो आपका अनडिस्टर्ब पोजीशन से डिस्टर्ब पोजीशन तक का डिस्टेंस होता है, दैट इज नोन एज योर एम्पलीट्यूड. द एम्पलीट्यूड of a sound wave is the height of the crest and trough. See, this is your graphical representation. So this is your amplitude. ये आपका क्या है? अनडिस्टर्ब पोजीशन है. यहाँ से जब वेव पास होती है तो यहाँ ये आपका जो पार्टिकल है इट विल गेट डिस्टर्ब्ड. क्लियर? तो इट विल फॉर्म अ वेव. सो द मैक्स फ्रॉम द मिनिमम टू द मैक्सिमम, दिस इज नोन एज योर एम्पलीट्यूड. इज दिस क्लियर? So, the maximum displacement of the particles of the medium from the original undisturbed position when a wave passes through the medium is called amplitude. The amplitude of the wave is same as the amplitude of a vibrating body producing the wave. Clear? Now, the next one is pitch. The next one is pitch. Basically, the pitch of the sound is shrillness or the flatness depends on the frequency of the vibration. Depends on the frequency of the vibration. If the frequency is high, your sound will, your pitch will be high, and if your frequency will low, your pitch will be low. So the pitch of the sound is shrillness or flatness depends on the frequency of the vibration. If the frequency is high, the sound has high pitch, and if the frequency is low, the sound has low pitch. The waves are all in the first the waves are all traveling at about same speed. So this is the number of each wave that will reach the ear in the human that of a second. Short wavelength means lots of waves, high frequency and high sound. Long wavelength means fewer waves, wavelength frequency and low sound, low wavelength, low sound, low frequency and low pitch. Since the sounds are traveling at about some same speed at the one and the shorter wavelength will go by more frequently. It has higher frequency or a pitch. In other words, sound is higher. Clear? If I am saying that frequency is higher or pitch is high, that means your loudness of the sound is higher. The next one is speed of a sound. The distance traveled by a wave in 1 second is known as your speed of sound or velocity of sound. The speed of sound is different in different medium. Speed of sound is different in different medium, and the speed of sound is more in solid, less in liquid and least in gases. That means सबसे ज़्यादा किस में होती है? Solid में. After that in liquid and after that in gases. So the speed of sound also depends on the temperature of the medium. If the temperature of medium is more, if the temperature is more, इन फर्स्ट चैप्टर ऑफ केमिस्ट्री वी हैड देन ना, अगर आपका टेम्परेचर ज़्यादा होगा तो पार्टिकल्स क्या होंगे? ज़्यादा वाइब्रेट होंगे. Is this clear? So like this, if the temperature of the medium is more, the speed of sound is more. And there is a relationship between frequency and wavelength and speed. What is that? Speed is represented by V, is equal to wavelength is represented by lambda into frequency. It is small f now. So V is equal to lambda into f. Clear? Now, what do you mean by wavelength? Basically, a wavelength is a minimum distance in which a sound wave repeats itself like this. This is sound. So यहाँ आपका ये वेवलेंथ है पूरा, क्योंकि यहाँ से ये फिर से रिपीट करेगी. So it is your wavelength. Is this clear? The minimum distance in which a sound wave repeats itself is called a wavelength, and its SI unit is meter, and it is represented by lambda. It is a Greek word. It is represented by a lambda. It is a Greek word. Is this clear? Now our next topic is reflection of sound. This we have done in our A standard. Like light, sounds get reflected in the surface of a solid or a liquid and follows as the law of reflection. The angle of incidence, angle I, is equal to angle R. Clear? The angle of incidence is equal to the angle of reflection. The incident ray, the reflected ray, and normal at the point of incidence all lie in the same plane. Okay, they all lie in the same plane like this. Clear? Now you can do this activity at your home. Take two pipes of the same length and arrange them on a table near a wall or metal plate. Keep a clock near the open end of one pipe and try to hear the sound of a clock through the other pipe by adjusting the position of the pipe. Now measure the angles of incidence and reflection. Then lift the second pipe and try to hear the sound. It will be seen that the angle of incidence is equal to the angle of reflection. The incident ray, the reflected ray, and normal all lie in the same plane. This activity you can perform at your home. So here your sound chapter, basically I have covered all main topics or the introduction. Basically this chapter has deleted from your syllabus, but I want to give the introduction about this chapter and some topics which is basic of this chapter. Clear? All the best for your exams. Do study very well. If you have any doubt, you can contact me anytime. Thank you and Sairam.